Okay, how many years from now, in your opinion, will it take to lift a 300-ton airship into the air? And do you have such a goal? I don't know, in how many years? 300 tons. A goal can be stated, but for now that goal is very distant. We should lift a smaller one for now. Well, and even within our project there is no such task to build such an airship. You see, I don't think it's economically feasible at all. I often give the example of the largest airplanes. How many such apparatus are needed at all for 300 tons? I think you need a maximum of 5 to 10 of them in the world. And it won't pay for itself. You need very few of them. I mean, if it were to appear tomorrow, it would probably pay for itself very well. But to build it, you have to invest so much money and so much effort, and take so long to build it, because it's a very serious machine. And for it to pay for itself, well, if the state decides this, there will be some tasks that cannot be solved in any other way. Well, it must appear. It must not just appear, it must appear and make itself known so that it is included in logistics chains. Where does it need to be? When some reactors are made, which are customized on site, where they're used, a whole factory has to be built for them, if they are transported in parts. And companies that build some, well, chemical reactors, or nuclear reactors, nuclear power plants, or some other huge structures, they are now put in a different logistic chain. They're not going to do it for an apparatus because a facility is built that costs billions or dozens of billions of dollars. And no one is going to include an apparatus which doesn't exist yet in logistic chains. So it turns out that they won't fund it, and someone has to fund it, and then just wait for it to be applied. I don't know. It's very complicated. I think that 60 tons is a good load capacity. And we should strive for it. Because if you carry 60 tons, you carry any kind of cargo. All freight is now standardized to a maximum of 60 tons.